Assalamualaikum warahmatullahi ta'ala wabarakatuhu. My name is by Almira and Locke, and my report is Kinematics of Rigid Bodies about translation. Okay, so ano nga ba ang kinematics of rigid bodies? It's a branch of classical mechanics that describes the motion of points, bodies, and system of bodies without considering the mass of each or the forces that causes the motion. Kinematics explain the terms such as acceleration, velocity, and position of an object. So, ang kinematics sa rigid bodies daw, pinag-uusapan dito ang tungkol sa motion ng isang bodies. Unlike sa statics, is walang motion na nagaganap. Sa kinematics of rigid bodies ay merong motion, pero hindi kinokonsidera dito ang mass or yung loads or di kaya yung forces na nagkakos ng isang body para magkaroon ito ng motion. So, ang kinematics daw ay explain dito ang acceleration, velocity, and position of an object. So, sa kinematics of rigid bodies, meron tayong types of motion, which is translation, rotation about fixed axis, general plane motion, motion about a fixed point, and the last is general motion. Ano nga ba ang translational motion? So, ang translational motion is a motion in which all points of a moving body move uniformly in the same line or direction. The motion by which a body shifts from one point in space to another. Example, from position A to position B. So, ang translational motion na sinasabi is ito na yung isang body or isang object na nagmo-move parallel to the path. For example, sa isang straight line, so nagmo-move lang siya doon parallel to the straight line. Ang example nito is halimbawa, ito yung object natin. So, ito yung straight na line or straight path. So, from dito, point A, ito point A, is mag-move siya papunta sa point B. So, yun yung tinatawag na translation. So, sa translational motion, meron tayong two types, which is, ang una-una is rectilinear motion. Ang rectilinear motion is when a body move along a straight line. The position, velocity, acceleration of particles moves along a straight line. So, ito na yung sinasabi ko kanina. Ang rectilinear na sinasabi is nagmo-move lamang siya sa isang straight line or straight path. For example, dito sa nakikita natin, merong isang sasakyan. Ito yung body natin. Ito yung object natin. So, nagmo-move lamang siya dito sa straight path na ito. So, for example, ito is nanggaling siya sa point A and then pupunta siya sa point B. So, nabago na yung position natin. Mula sa position A, papunta sa position B. Ayan, tumatakbo din siya sa straight, along a straight path. So, ito example din ng rectilinear motion. Basta ang rectilinear motion is, nagmo-move lamang ito along a straight line. Meron tayong formula for rectilinear motion. So, una-una dito sa constant acceleration, una-una is yung velocity natin. Yung final velocity, ito, final velocity natin is equal to initial velocity plus acceleration times time. Pangalawang formula naman is a formula ng displacement natin. Ito, initial velocity times time plus 1/2 times acceleration times time squared. So, another formula for final velocity. Pag wala tayong given na time, pwedeng ito yung gamitin natin pag ang given ay distance. So, v squared is equal to initial velocity squared plus 2 times acceleration times distance. Okay, so pangalawang types ng translational motion. Nasabing curvilinear motion is when a body moves along a curved path. The position, velocity, acceleration of particles moves a curve. Okay, so sa curvilinear motion naman, yung kanina rectilinear which is straight line lang. So dito naman sa curvilinear is curve path. Ito siya, curve path. Makikita natin sa example. Ayan, curve path. Ito is circular. So for example, ito yung object natin. Ito yung object natin, yung sasakyan dito. And then nagmo-move lamang siya in a circular path. So dito, parehas din, curve path. So, yun yung pagkaiba nila. So, rectilinear motion is straight path at dito is curve path. So, the best example natin for curvilinear motion ay yung solar system, which is yung Earth natin is nag-evolve around the Sun. Ito yung Earth natin, and nag-move lamang siya sa curved path. Yung position vector is mula sa center, which is yung Sun, from Sun to the Earth, at yun yung position R natin. Sa X and Y axis, for example, ito yung Sun natin, at yung Earth natin, and the position from the Sun and the Earth is the position R, which is also the magnitude. At mahanap natin yung magnitude using the Y vector, the vertical, and the X vector. So, ito yung formula na gagamitin natin para mahanap natin yung position R. Position R is equal to the square root of X squared plus Y squared. Gamit ito, mahanap din natin yung velocity at saka acceleration. So, sa acceleration natin can be determined gamit yung normal acceleration, which is perpendicular to the path, and also the tangential acceleration, which is parallel to the path. Para makuha natin yung normal acceleration, which is yung perpendicular to the path, ang gagamitin natin is v squared all over p. At para naman sa p natin, ito yung magagamit natin na formula. Okay, so meron tayong examples para sa translational motion, which is the rectilinear motion. So, Josh accelerates from rest at 4 meter per second squared. So, ang hinahanap natin is how fast is he moving after 10 seconds and how far did he travel. So, ang given natin dito is meron tayong acceleration, which is 4 meter per second squared, at ang hinahanap natin is how fast he moving after 10 seconds. Yung final velocity natin, at how far did he travel, yung distance. Okay, so dito ang gagamitin natin na formula para sa final velocity is yung final velocity is equals to initial velocity plus acceleration times time interval t. So, i-input lang natin yung value. So, ito na yung magiging final answer natin, 40 meter per second. So, ang hinahanap naman natin is ang distance. So, based dun sa formula na binigay, ang distance natin is equals to initial velocity times t plus 1/2 of acceleration times t squared. So, i-input lang natin yung value natin. So, ito na yung makukuha nating distance, 200 meter. So, sa example, problem number 2, example natin sa curvilinear motion. So, an airplane travels on a curved path at P. It has speed of 350 km per hour, which is increasing at a rate of 1 meter per second squared. So, ang hinahanap natin is the magnitude of total acceleration. Pangalawa naman is angle made the acceleration vector with the positive x-axis. Meaning, yung angle natin dito. Ito yung makikita natin sa figure. Yan yung gagamitin natin sa pagkuha ng magnitude of total acceleration. So, ang formula natin for magnitude of acceleration is yung AX is the A normal and the AY is the A tangential. So, since given naman yung A tangential natin, which is 1 meter per second squared, ang mahanap lamang natin para makuha ang magnitude of total acceleration ay ang A normal. So, para makuha ang A normal, gagamitin natin yung formula ng A normal, which is ito. Which is A normal is equal to V squared all over P. Since wala tayong value ng P, hahanapin muna natin yung value ng P gamit ang formula na ito. So, una-una is i-convert muna natin yung given speed, which is 350 km per hour into meter per second. So, meron tayong 97.22 meter per second. So, gamit ang equation ng curve, which is ito. So, by double derivatives ng given na equation, mahanap natin ang position at x is equal to 5 km per hour, which is ito. Now, gamit ang formula ng radius of curvation, isa-substitute lang natin ang value at mahanap natin ang radius of curved path. So, ito, isa-substitute natin yung value at makukuha natin ang 52.704 km, which is 52,704 in meter. Ngayon, alam na natin ang radius, mahanap na natin ang A normal. So, input lang natin ang value. Ito. So, makakuha tayo ng A normal na 0.179 meter per second squared. So, since meron na tayong A normal at given na rin ang A tangential, so, input lang natin at makukuha natin ang magnitude of acceleration which is 1.015 meter per second squared. So, ang next naman na hinahanap ay yung angle made by the acceleration vector with the positive x-axis. So, now, let theta be the angle na nagawa ng acceleration vector tangent sa x is equal to 5 km. So, tan theta is equal to an all over 80, which is tangential, at makukuha natin yung theta na 10.148 degrees. So, ngayon naman, ang hinahanap natin is yung angle alpha. Mahanap natin ang angle alpha gamit ang given na slope sa curve, which is yung 3. Ngayon, i-compute natin, i-input natin yung value. Alpha is equal to inverse tan 3 is equal to 71.56 degree. So, ito na yung angle natin made by the acceleration vector with the positive x-axis. At kapag hinahanap naman natin ng total angle, madali na lamang yon sapagkat i-add lang natin yung dalawang angle na nakuha natin at makakakuha tayo ng angle na 81.71 degrees. So, yun lamang ang aking report. Again, my name is by Almira N. Locke and maraming salamat po.